welcome to Pop Bottle Science with Miss Taryn. So, what we're going to do today is I'm going to show you a few experiments that you can do with this really cool Pop Bottle Science kit that you can pick up for free at the library beginning today. So, we have plenty of these, so come by, pick one up, and it has, I'll show you what all is in here. Get it undone here. All right, so it has a book that I have bookmarks and pages in. Here's one I have bookmarks, but it's Pop Bottle Science with 79 amazing experiments that you can do at home. For many of the experiments, you'll actually use this pop bottle, and there are also some other materials that you may or may not use for different activities. I am going to use it today to show you a few of my favorite activities from this book. All right, so I'm going to take out the extra packaging and just set it over here to the side. But I wanted to show you what you got once you pick up the kit. Okay, so you'll also have a typed sheet of all the experiments that I'm going to do today, along with the pages that they're on, so you can follow along either with these or pick out some from the book that you'd like to do. Okay, all right, so let's get started. For our first experiment, we are going to do the lava lamp experiment, which is on pages 3 and 4. So the premise of this is, why doesn't oil mix with water? Okay. So, after we finish the experiment, we will know the answer to that question. All right, so I've got the different materials for each of my experiments laid out. So, let me get the first one ready here. So, what we need for the lava lamp, and you'll see on your sheet the materials that you'll need to do this experiment. Okay, so you'll need an empty pop bottle. So, something like this. It can be Coke, pop, whatever you want. I think mine's a sparkling water. You'll also need some vegetable oil. You'll need food coloring and tap water. Okay, so on the instructions, we're going to fill the bottle about 1/3 of the way full with vegetable oil. All right, now let's see if I can do this without making a huge mess. All right, so parents, if you're watching this, you may want to do this part for your kids, but you also may be using a vegetable oil container, and it won't be as potentially messy as this one will be. Okay, so it's not super bad. All right, that's probably good. All right, so I've got my vegetable oil about 1/3 of the way full. And next I want to add 2 drops of food coloring. And it can be any color you want. So I just picked blue. 1, 2. Okay. So now you can kind of see it. There's 2 little blue dots that are floating down to the bottom. Okay, yep, now they've floated. Now what we want to do is fill the bottle up all the way with water. Okay, so once you fill it up with water, look at it. That blue is no longer sitting on the bottom, is it? It has changed colors, right? It's changed the color of the water, and it's also kind of made this vegetable oil polka dotted. There's blue specks all over it. All right, so I'm gonna close it, and our instructions say to let it sit for a few seconds and observe it, and then we can shake it up, move it back and forth to see what we observe. All right, so we've seen it. So what's happening now is that blue food coloring is coming down from the top here and going down back into the water. Okay, so if we go like this, You can move the water back and forth and the oil. It's pretty cool. It does look like a lava lamp. That's what this one's called. It's called a lava lamp. So why is it doing that? Our water is always staying separated from our oil, right? Okay, so our book provides a very simple explanation for this, and it has to do with the weight of each material, okay? So water is heavier than the vegetable oil. So that means that the water is going to sink to the bottom and not mix with the oil, okay? The oil will slide up to the top. And the food coloring mixes with all of it, but yeah, this is really, the focus is on the oil and the water. Now, the coolest thing to me about this is how each little part of the vegetable oil has like tiny, tiny blue dots embedded in it. So you can look at it on your own when you do this at home, okay? So that is our first experiment. Super fast, right? Really easy. So our next one is called Color Show. And this one is about liquid fireworks. So it's a little bit similar. It also has to do with the weight of different materials. Okay, so I'm gonna set this one aside. So for this one, we need stuff over here. We need a tablespoon. We need more vegetable oil, which I have here. We need a jar that is empty with a lid. Okay, next we need food coloring, but we don't just need one color, we're gonna actually do several. So I have 3. I have blue, pink, and yellow. Okay, and now for this one, we are going to use your pop bottle with the top removed. So when you pick up your kit, you're actually gonna use this one. So we're gonna take this part off, and we're also going to use water. So first of all, we're going to measure 1 tablespoon of oil into the jar. Okay, so we're gonna have 2 different containers going on here. We have the jar and we have the pop bottle. Okay, so I'm gonna get my tablespoon out here. Careful to make sure I get it measured correctly. Okay, so tablespoon of oil into the jar. I'm gonna set this aside, and I want to put 2 to 3 different colors, 2 to 3 drops of each different color into the jar. All right, start with my blue again. It's my favorite color. So I got 3 dots down there. Got my pink. Okay, so if you're doing this at home with your siblings, I know if I were doing this with my brother, we would probably fight over who gets to do what. So this is a great opportunity to share time. So maybe one of you puts one color in, the other puts a different color in, okay? So please divide up your responsibilities so that everybody gets a chance to work together. And I've got the food coloring on my hands because I'm messy. All right, and our yellow. All right. Now we are going to tightly screw the lid on the jar and begin shaking it. Woohoo! All right, so there's not much in here, right? Okay. How does it look to you? Kind of gross, right? It's not very colorful. You can see pieces of the colors on it, but it's mostly just kind of gray. Like all the colors have gone together. All right, so now we're gonna use our big pop bottle here. We're gonna fill the bottom half of it mostly full of tap water. I left a little space up here. Okay. All right, so next, I'm going to pour the oil and food coloring mixture on top of the water using the top part of the pop bottle as a funnel. Okay, So I want to unscrew this cap here. Pretty cool, huh? All right, so for this part, it is helpful to have multiple people. So this is where you and your brother or your sister can work together. Okay, so I'm gonna pour the oil and food coloring mixture on top of the water and see what happens. So I want you guys to watch it as I'm doing it. Ooh. All right. Pretty cool, huh? Okay, so you can't really see much straight on, but if you look at it from above, each part has separated. So that oil has separated again, but now we have the different colors going on. All right, so like we learned in our last experiment, water is heavier than oil, right? Okay, another word for that, another science term for that is it's denser than oil. So when you mix the oil and the water together, they will always separate. Food coloring is mostly made up of water, so it drops through the oil and down to the water, which is what is starting to happen here, okay? So the food coloring, the colored food coloring and the oil have made little drops on the top, but our food coloring, you can just barely see it, it's starting to come through, starting to come down from the top. Okay, so food coloring is mostly made of water, so it is also what? Heavier than the oil. All right, so when the bubbles sink, which is what's starting to happen, the oil coating that was connected to them rises back to the surface. The tiny color drops seem to disappear because each small drop of coloring is not strong enough to change the color of the water. So eventually what's going to happen is all the tiny drops are going to sink to the bottom and the color of the water will change. It's pretty cool, isn't it? So that's why it's called color show. And if you look at the top of it, which is hard to see in a video, but if you look at the top of it, there are lots of tiny little drops of the food coloring on the top. And they are slowly working their way down here. Okay. All right, so that is our second experiment. And we're gonna leave it as it is right now. And just kind of watch it for a few seconds. We're gonna need it for the next couple of experiments, so I want you to see as much as you can. All right. So it's slowly moving down, so that's why this is called fireworks or the color show, because all the color is starting to come down. And the yellow didn't work out so well. It's not coming, I'm not seeing it at all. I'm seeing the blue and I'm seeing the pink for sure. Mostly the blue, but I'm not seeing any yellow. So if you're doing this at home, maybe yellow is not gonna show up as well for you either. All right, so that's the color show, that's the fireworks. I'm gonna dump this out so we can get started on our next part, okay? And I just want to rinse it out because I don't want, well, it still has some gunk in it, but that's okay. I'm going to kind of hand dry it. But our next one, I'll tell you about that while I'm getting this clean. The next one is called Moon Surface, okay? So this one is more of a practical activity to learn about how the moon got craters. Is that something you've ever wondered about? Or maybe it's something you've learned about in science class? This is like a hands-on way to experience how the moon got craters, okay? All right, so that oil, this is just what the oil does. That oil has gotten all over this and made it very greasy, but that's okay. It's gonna work just fine without that. Okay, so it did get food coloring all over this here. I'm gonna rinse it out one more time. All right, I think we're good. So our next experiment is called moon surface. So that's what we need this here and these materials for. All right, so here's what we need for the moon surface experiment. We need 2 cups of flour, which I've already measured out. So you can go ahead and measure it out right now. You need your pop bottle without the top, so I have that. And then some small objects. So nothing probably very much bigger than this little bitty teddy bear. Okay, so I have the teddy bear, I have some marbles, I have a penny. You can use chocolate chips, you can use raisins, beads, whatever you have handy. Okay, so first of all, I'm going to take the flour and put it inside the bottle. Okay. And this part may be messy too. I'm getting the flour on my hands as I'm pouring it in here. If you're using just a cup of flour, instead of getting it out of this big container like I am, yours probably won't be as messy. Okay. All right, cool. All right, so we've got our flour. The next thing we want to do is kind of shake the sides to make sure it is even. Okay, so I want all of the flour to be the same level in here. Okay, so it should look the same. All right, now you want to place the bottle somewhere it is safe to get messy. So this island, this kitchen island, is pretty safe to get messy for me. If you need to go outside to do that, that's fine. If you want to get a pan or like lay down some trash bags or whatever you want to do, because you may be getting flour kind of spurting everywhere. Okay, so now what you're going to do is stand above the bottle and you're going to drop your small objects onto the flour. And first we're going to start off by dropping it gently. Okay. So I felt like that was gentle, but, and this is the part you'll get to experience at home. When I look at it, it has totally changed the top surface of my flour. Okay. So maybe I shouldn't hold it up so high. Do you think maybe we'll try the marble like down lower? Okay. So looking at the marble, so the marble is almost completely swallowed up by the flour. If I move it, it's gonna kind of disturb it. So I'm not gonna move it, but you guys can kind of see from here. All right, so I also wanna take a penny. So depending on how hard you drop your objects, your materials may act a little differently. Okay, the same thing happened as with the marble. I had the penny closer to the flour and it fell into there and almost got swallowed up by the flour. Okay, I'm gonna try another big bear here. Maybe I'll drop him closer. Okay, so now the bear has covered up with the impact of his fall. He's covered up both the penny and the marble. All right, so our explanation for this: when our solar system was forming, space debris hit planets and our moon. So that created deep craters. Now, as you know, the Earth does not look like the moon, right? Looks pretty different. So the Earth was covered in craters at some point, but since we have an atmosphere that has led to changes over time due to erosion, rivers, waters, natural disasters, things like that, our planet's surface has transformed over the years. But the moon does not have an atmosphere like we do on planet Earth. So there are no storms, there's no wind, no weather, rain, anything like that to change the surface of the moon. So while the Earth has always been changing since the beginning of whenever all this happened, the moon looks the same as it did millions of years ago, which is pretty cool. So you can look inside your pop bottle and see what's left over and what kind of impact those craters left. So like this, I know that it's not solid, right? It's not flat like it was at the beginning, flat and smooth. I have all these marks in it, and it's covered up other craters. Bigger ones have, you know, disturbed the entire surface of it. Okay, so show you a little bit what it looks like inside there, but yours will look different from mine. So that's a little bit about how the moon's surface changed, or has not changed, sorry, how the moon's surface has not changed over time. Okay, so for our last experiment, I'm also going to use this pop bottle again, and I want to pull out all of my materials here. I'm just going to dump these all back in here for now, and I will clean up later. I do want to make sure that I get as much of this flour as I can out, because our next experiment does not involve flour. It involves water. All right. So while I clean this one out, and talk to you about our next experiment. So this one is my favorite, and this is something that you may have done before, or maybe you've never had a chance to do it. I first saw this experiment on Pinterest, and I thought, I really want to do this for the library. And then it just didn't work out. So now I finally got the chance to do it because of this cool pop bottle science. It was one of the experiments in pop bottle science. So I am very excited to show you this one. And flour doesn't want to come off, does it? So let me rinse it out again. All right, so you may have some pieces of flour. Of course, depending on how much, if you do all these experiments in the same order, it may look different for you. All right, so our next experiment is called Flower Power. How do plants get water from the soil? A great question. Okay, so what you'll need for this one is food coloring. You can pick whatever food coloring you want. I'm going to pick pink. And you're going to use your pop bottle. You're going to use a white carnation, which is what I have. Now, if you don't have a carnation handy, so they are at, I was able to get this at Kroger. You can also get it at Walmart. If you don't have carnations, you can get a white daisy or a white rose. So those are the 3 different types of flowers that will work for this experiment, okay? And they do need to be white. All right, so I am going to put the top back on my pop bottle. So first of all, I'm going to put several drops of food coloring in the pop bottle. Let's see. Ooh, okay. Got quite a bit for that one. Now I'm going to fill it full of tap water with 1 inch of space on the top. Okay, so one thing you want to make sure about your pop bottle, if you just set the lid on it, it will be open. So you want to lock the lid in place. Okay, there's like a little latch on the side. Okay, I'm gonna fill up with water, and I somehow got food coloring on me again. All right. Now, want to fill it up a little bit too tall here. Okay, that's okay. All right, so I want to use this part underneath where the pop bottle screws off. So I don't want to fill it up higher than that, okay? So I have now filled it full of water and I have a little bit of space on top. So now I'm gonna stick my flower in here. Okay. So now we wait. Let's see what happens. So while we're waiting, do you have any ideas on what's going to happen to the flower? You probably do, because we have food coloring in here, right? And a white flower. So I'll go ahead and tell you the explanation as it happens slowly. All right, so we put several drops of food coloring in our pop bottle, right? Okay, and then we set our flower inside that water. Okay, so the white flower becomes a different color because plants are like suction machines. So suction means you like suck it up, basically. So like a vacuum, if you want to think of it that way. They need to have this power in order to get water from the soil so that they can survive. So when they are planted in the soil, a plant's roots pull that water in out of the soil. Once the water from the rain or from your watering can or however that flower gets water, once it is inside the roots of the flower, it's pulled up and into all parts of the plant. Now in this experiment, obviously we don't have dirt, we don't have the roots of the flower, but the flower has been sitting in the water, okay? So with or without its roots, it's going to be affected by it. All right, so once the water's in the roots, it is pulled up and into all parts of the plant. Now it may take some time in order for it to work, but this experiment shows you the pathway of the water and how a flower drinks, okay? So it would kind of be like if we had see-through skin that would allow us to, if we drank a Mountain Dew, we could see the yellow Mountain Dew going down our throats, that kind of thing. So in the same way, the flower is drinking this water and absorbing it for its nutrients, okay? So it is taking a little bit of time to suck up that water. All right, guys, so it's been a few days later since I did our experiment with the white carnation and the pink water. You guys remember that one? So what I found out was that it didn't work. And I'm not sure what went wrong with it, but these two flowers right here in this vase are the ones that I had in the pink water for almost a week before I finally just gave up and put them back in the water with the other flowers. So I just wanted to let you guys know that the white carnation flower did not work for me, okay? So sometimes science experiments are just that. They are an experiment that fails. Even if we do everything right, sometimes the variables that impact the different parts of the experiment are too great to allow us to have a successful experiment. So I wanted to come back a few days later and let you guys know that you are still obviously more than welcome to try this experiment. Maybe you'll try a different flower. Maybe you'll try a different color. Maybe you'll try opening up the stem a little bit. I wondered if that was what may have caused this experiment not to work for me, but when I trimmed the stems here, it did open up, expose the skin a little bit here, the inner part of the flower, inner part of the stem. But it's still the same color that it was before I put it in the water. So I don't know, maybe you'll get this experiment to work. So either way, let me know in the comments how it goes for you with any of the experiments that we practiced. Or if you did some of the other 75 experiments that the Pop Bottle Science book contains, let us know in the comments. Show us a picture of it, or let us know how it went for you. So these kits are available to pick up beginning today on a Wednesday. So please come by, grab one. One is enough for the whole family because they are activities that you can do together. And the book has all different types of instructions, so many different options that you can choose from of experiments. I just chose a few that I thought would be fun to show you today. All right, I think that's everything. If you have any questions, just contact us at the library, and we'll see you later.